Hi everyone. Today we're going to be talking about theoretical versus experimental probability. I should actually say 8.4, not 8.3. We're going to calculate theoretical probability and calculate experimental probability, and then also use probabilities to make predictions. So, what is theoretical probability? Everything we've done so far has really been theoretical probability. It's a chance that something's going to happen. We calculate it using math. For example, what's the probability of getting heads when you toss a coin? 1/2, or one head out of two possible outcomes, which is also 50%. So if you were to say, what do you expect to happen? You expect that if you toss a coin, about 50% of the time, you'll get heads. When you roll a number cube, what's the probability that you'll get a 3? Well, there's 1 3 on a number cube out of 6 possible outcomes. So 1 out of 6, or about 17% of the time, you would expect to roll a 3. This is all the stuff we've done before. Now, looking at my spinner over here, what's the probability that if I spun it, I would get a green? Well, 1/4 of the colors are green, and it's evenly divided. So green doesn't have more of a chance because it's not big or anything. So 1 out of 4 should be green. So if I spun this, 100 times, I would expect to get green about 25% of the time. So that is theoretical. It's what we've been dealing with all along. But now we have experimental. This is what happens if we actually do it. What happens? So, for instance, I'm going to spin the spinner 15 times and record what happens when I spin it. So there's 1. I get a green. We put a tally mark. Then we spin it again. 2. 3. I shouldn't have to keep switching between pen and not pen. It takes up a lot of time. 4. Another red. 5. 6. Red seems to be winning. 7. 8. 9. 10. 11. 4 more to go. 12. 13. 14. And last but not least, 15. Now, when I actually did this experiment, I got 2 greens, 5 reds, 3 blues, and 5 orange. That should add up to 15, and it does. So my experimental probability is, out of my 15 times I spun it, 2 of the 15 were green, 5 of the 15, which is the same as 1/3, was red, 3 of the 15 were blue. That's 1/5. And again, 1/3 also for orange. So what went wrong? Why didn't I get 1/4, 1/4, 1/4, 1/4? Well, experiments don't always turn out the same as you think they will. Does that mean the spinner's defective? No, just means we didn't do it enough times. If I did this 1,000 times, probably get closer to my theoretical being the same as my experimental. But when you do a short little study, your experiment will probably get different results. So green 2 out of 15, red 1 out of 3, blue 1 out of 5, and orange 1 out of 3. If I said which one of these is closest to the actual theoretical, well, out of 15 times, 15 is not a very good number. If it was 16 times, I would expect each one to be 4. So somewhere close to 4. So that would be, I should actually figure out my actual theoretical, but it is actually 15 divided by 4, but close enough. Both of these, all three of these are pretty close. They're all 1 off. This one is quite a bit off. Just like if you toss a coin twice, will you for sure get a heads once and a tails the next time? Probably not. But if you do it 1,000,000 times, you'll probably get pretty close to half and half. So that's theoretical versus experimental probability. You can also use probability to make predictions. So if I flip 2 coins 8 times, what's the prediction for the number of times both will land on heads? Well, how many different things can I have? I'm flipping 2 coins 8 times. Now, if I did my sample space, I would have a lot of different options. But I could list out everything I could have. I could have heads, heads. I could have heads, tails. I could have tails, heads. And I could have tails, tails. Those are the different options that I could have. So I expect to get both on heads 1 out of 4 times. But if I'm tossing it 8 times, this is going to be a proportion. If I tossed it 8 times, how many times would it get heads? What am I multiplying by? 2, right? So multiply by 2. I would expect that out of 8 times, I would get heads twice. Okay, let's look at this. I select a marble without looking, and then I put it back. I do this 6 times. What's the prediction for the number of times I would pick a pink marble? I have 1 pink marble out of 1, 2, 3, 4, 5, 6 marbles. So if I do this experiment 6 times, I would expect I could make the thing, but it's going to be out of 6. I could expect that I would do it 1 time, 1 out of 6. 1 time out of every 6 times I draw. Okay, let's look at this. If I pick a blue marble, I should pick a blue marble half of the time, 50% of the time. So if I do this experiment 4 times, how many times would I expect to pick a blue marble? I would expect to pick a blue marble 2 times, half of the time. Okay, today you're going to be doing some experiments with the partner. Before we get started, I want to make sure that people know a little bit about cards. First, how many cards are in a deck? There are 52, so fill that in on your worksheet. How many different suits are there? Well, there's diamonds, I don't know how well I can draw on this. Hearts, clubs. I can't draw a club very well. It's kind of like a clover. And spades, which is kind of like an upside down heart, but with the stem. These two are black. These two are red. So how many of each suit are there? There's 13. We don't count jokers, so you'd have an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king. So there are 13 of each one. So you can fill out this theoretical probability, just to show you an example, theoretical probability of getting a heart. Well, there's 13 hearts out of 52 cards. So 1 out of 4. So this is theoretical, what should happen, okay? So you can fill out this top. After that, you and your partner are going to do an experiment 25 times. Make sure you do it 25 times, which means every time you're going to take turn drawing a card. Then you're going to record it. So let's say you reach in, you draw a card, and you get a 3 of spades. Under my spades, I put a 3. Then I reach in again and get a queen of diamonds. Under my diamonds, I put a queen. We're going to do that 25 times, and we're going to record our results. And then we're going to answer these questions down below. When you're done with that, the back side of the worksheet is your homework. Have a wonderful day. Talk to you soon.